Removal of hardened cement deposited on PV panels and its effect on power generation. Abstract urban environment affects the power generation capacity of PV plant. There is various type of matter present in urban area. Dust from a construction site can be categorized as I. Silica dust, 2. Wood dust, 3. Low toxity dust like gypsum limestone, dolomite. When this dust gets deposited on surface of solar panel, they block sunlight from reaching cells. Shade and off photovoltaic panel affect energy output generation. Shade and off PV panel cause hotspot and other issue, thus decreasing the life of PV panel. For this background, the purpose of our experiment, I. Removing of hardened cement on glass at low rate possible, 2. Observing after effect of acid on PV panel, 3. Observing change in PR of solar PV plant before and after cleaning. The result of the experiment is increased PR of 86% and after 6 months of observation. There is no sign of damage due to use of acid for cleaning purpose. Keywords: anti-reflective coating, arc, mutric acid or hydrochloric acid, HCl, photovoltaic, PV, kilowatt-hour, etc. 1. Introduction. Analyzing current scenario, the world energy demand is rising day by day. Nevertheless, the prices of fossil fuel are growing exponentially. Along with fossil fuel comes environmental problems which are rising at an alarming rate. There is a huge gap between supply and demand of energy. It is being predicted by 2040 50% of energy will come from renewable source. 1. Solar energy, playing a major role in meeting future energy demand. PV systems have a life expectancy of 25 years. To ensure that they perform at full efficiency, maintenance of plants must be done regularly. Depending upon the type of system, O&M service differs for every PV plant. Every site has different problems, hence, innovation is needed. Existing method of removing cement include use of product which are expensive. This may also require more human time to manually remove and scrub each inch of area to remove cement. This scrubbing will definitely remove arc coating. We began by observing the site and trying out various methods to clean it. A small patch had been cleaned with HCl acid and result were satisfactory without any trouble of scrubbing. Nowadays many automation tools are available in market to remove soil from panel, but there is small segment present rooftop solar. The challenges are different from ground-mounted solar project. Along with soil, many other man-made and natural debris get deposited on module. Causes of deposition. At the site there is construction of 5-story building. The building is on west side of solar plant and about 7 meter apart. Thus cement particle size is 3 to 100 microns, hence it gets easily carried away by wind. The surface of panel is rugged, thus deposition of particle becomes permanent after it is allowed to settle over a period of time. Effect of shadowing. The cause of the hotspot could be a variety of cell failures, including partial shadowing. When a cell is shadowed, it could operate in reverse mode, in which the cell consumes energy instead of generating it. Shaded cell can overheat, and damage can occur in the cell or module. This can be considered a defect in the PV module too. The study revealed the impact of cement particles to be the most significant, with the 73G/M2 deposition of cement dust resulting in an 80% drop in PV short circuit voltage. 3. 2. System performance. The power output delivered by photovoltaic system highly depends on amount of irradiance, which reaches solar cells. Shading is divided into 2 categories, namely soft shading such as air pollution and hard shading due accumulation of dust particle. In our case it is hard shading and all solar cell were shaded by dust particle. The effect was observed as low voltage appearing across PV terminal, i.e. 100 V. 3. Methodology. A. Experimental setup. The plant was installed in 2015. It is a fixed structure facing magnetic south. The total capacity of 3 kW, DC, solar PV plant. Modern solar polycrystalline cell panels of dimension 1645 x 9542 mm, total of 12 panel. GROW8 3000 series inverter was used of capacity 3 kW, AC, was used. Efficiency of inverter is 97.6%. B. Different methods used for cleaning. I. Pressure, water, spray. 2. Vinegar and water. 3. Washing soda and water. 4. 1/2 cup of baking soda plus 1 gallon of water plus 1/8 cup of liquid dishwash detergent. V. Shampoo and water. By using above methods, we did not get satisfactory result, as this method are time consuming and requires too much hard work, so we decided to try different acidic solution for cleaning. Finally, we got better results from HCl solution. 6. HCl solution, 30% W/W. C. Calculation. Total area, 19.64 square meters. Solar insolation for that month, 5.22 kWh/m2/day. Panel efficiency after considering annual degradation, 245 W. Expected output, 12.5 kWh/day. Actual generation, 1.8 kWh/day. D. Duration of experiment. Reading of 3 consecutive days before and after cleaning the panels were taken. To observe the effect of acid on arc coating, we observed the panel for 6 months. The panel during this period were cleaned as scheduled without use acid or any other cleaning agent. E. Data collection. To compare and evaluate energy and power output between cleaned and cement deposited panel data collected for 3 consecutive days. Cleaning of panel included great care as no pressure can be applied or it will crack solar panel. The method used is same as acid etching concrete. Acid solution was 60% concentrated. Using it directly would have reacted with arc and damaged it. To avoid any damage to arc, solution was made with 1 part of acid mixed with 3 part of water. Chemical equations when diluted HCl react with cement are given below 6. The above reaction is exothermic and releases fumes. Now we discuss about the scrub time. The scrub was kept as short as possible. Hence as solution was poured it was allowed to react and scrubbing would follow immediately. Care was taken of not using metal scrubber, hence non-scratcher sponge were to clean the panel after thoroughly cleaning using solution. The panel were washed again with clean water to remove any other residue present. The total time required was 40 man-hour. There were few panel on which cement particle bonded together and made cement droppings. This dropping act as shadow for single cell, but reduces the electricity output of whole panel, thus creating a hotspot which increase the temperature of panel. These stain were hard to remove and can only be removed by using acid. For conclusion. After cleaning of panel following reading were observed. The main concern was after effect of acid on panel component like aluminum casing. After 6 months of inspection, the panel are working as new ones. There are no yellow patches formed which occur due to damaged arc. Aluminum is damaged due to acid. Hence it is advised to only use acid when above condition of cement deposition occur and not to use on regular O&M. Hard water used for cleaning of panel can accumulate over a period of time and cause scaling. This scaling cause reduction in electricity generation and become hot spots. This scaling can also be removed by acidic solution.